Welcome to this short introduction to the new predictive maintenance functionality introduced in Witness 22 Horizon. We're going to look at how predictive maintenance can be represented in a model and explain the steps to introduce it into a model for yourself. The key to predictive maintenance is to monitor the condition of a machine and perform maintenance at a scheduled point in time when the maintenance activity is most cost effective and before the equipment fails. This example comes with the installed version of Witness. A failure on machine 1 takes 25 minutes to repair after failure, but maintenance activities can be completed in just 1 minute. There's a condition monitor that gives an average 12 minutes warning before a failure occurs, and it takes an average of 10 minutes to prepare for that maintenance event to take place. If we rerun the model, we can see how this view builds over time. As each trigger warning is raised, the maintenance or the failure happens depending on whether the response can be made in enough time. So here we take too long to respond and therefore we have the full failure. So how do we build this into the model? Let's have a look at the detail for machine 1. There are a number of components that we need. If we look at the breakdowns tab, we need to define a standard type of breakdown to represent the failure. This is defined as it always would have been, with available time, with a time between failures on average of 50 minutes and a repair time of 25 minutes. And note that this is breakdown number 1 in the list. Next, we need to create our predictive maintenance event. This must be of type triggered, and we define the time until the event happens, in this case on average 10 minutes. The time to carry out the predictive maintenance is 1 minute, and note this is breakdown 2 in the list. Because this new breakdown is triggered, it won't take place until the condition monitoring is added that triggers it. So in this example, I've added the condition monitoring to the actions on start of machine 1, but you could model the monitoring logic anywhere within your model. So in the actions on start, this shows 2 of the new functions that are now in Witness. The first I check is the amount of warning the machine is going to get before it breaks down. To do this, I've sampled on average 12 minutes and then use the breakdown interval remain function to compare how much time there is left until the failure is going to occur. If the condition is triggered, I then call the new trigger breakdown function to link together breakdown 1 and breakdown 2, the available time failure and the triggered breakdown, to start the time counting on the time until the predictive maintenance will happen. So if we run the model again, we can see where the trigger is being called, where we have the triggered period, and mostly the predictive maintenance does happen, but sometimes we do get the actual failure where we've not got enough time to respond. This process is also described in the help for predictive maintenance, where we can see the effects of a predictive maintenance event that either does happen or does not happen in time to prevent the failure actually taking place. Including this in your models will help you determine the cost versus benefit of adopting predictive maintenance technology at all, and then help determine the right sensitivity for your condition monitoring to ensure that the maintenance activity is most cost effective and before the equipment fails.